Hey guys, welcome back to the course. In this video, I will teach you about another suitable example of line integral. So the statement of the example is if phi is equal to x y squared z plus x squared y, evaluate the line integral c phi dr, where c, the first part of this question is the curve x is equal to t, y is equal to t squared, z is equal to t cubed from t0 to t1. And second part of this example is consists of the line segment C1 from 0, 0, 0 to 1, 0, 0. Then the line segment C2 from the point 1, 0, 0 to the point 1, 1, 0. And then the line segment C3 from the point 1, 1, 0 to the point 1, 1, 1. So let's start to solve this problem. First of all, we write the given data. You know that we have given the value of phi. So we write the value of phi. Phi is equal to 2x y squared z plus x squared y. This is equation number 1. Let's go to the line integral formula. You know that line integral formula is integral c phi dr. Line integral formula we have to solve three things. Then we putting these three values in line integral. Then we calculate the line integral easily, which is first phi, second dr, and third is limit. Phi already given, but dr is not given. So first of all, we write the value of dr. For this purpose, we write the position vector, and position vector is r is equal to xi plus yj plus zk. This is equation number 2, and dr, which is equal to dxi plus dyj plus dzk, which is equation number 3. So let's start to solve the first part of this question. So putting x is equal to t, y is equal to t squared, and z is equal to t cubed in equation number 1, and we have phi is equal to 2 into t squared to the whole square into t cubed plus t squared into t squared. So after multiplication, and we have 2t to the 8 plus t to the 4. So this is a value of phi, and putting x is equal to t, y is equal to t squared, z is equal to t cubed. It means all values of x, y and z in equation number 3. And we have dr is equal to dti plus dt squared j plus dt cubed k. And we know that dti as it is plus and derivative of t squared, which is 2t. So dt squared j is equal to 2t dtj plus derivative of t cubed, which is equal to 3t squared dtk. After some calculation, and we have I plus 2t j plus 3t squared k into dt. And you know that in first part of this question we have given t varies from 0 to 1. So these are limits of t. So putting limits value of phi and dr in integral formula, and we have integral c phi dr, which is equal to integral 01 2t to the 8 plus t to the 4 into I plus 2tj plus 3t squared k into dt. After multiplication, and we have 2t to the 8 plus t to the 4I plus 2t into t to the square 2t to the 8 plus t to the 4 into j plus 3t squared into 2t to the 8 plus t to the 4 into k into dt. After some multiplication, and we have 2t to the 8 plus t to the 4 into I plus 4t to the 9 plus 2t to the 5 into j plus 6t to the 10 plus 3t to the 6 into k into dt. So integrating all of these, and we apply the power rule of integration, and 2t to the 8, which is equal to 2t to the 9 over 9 plus t to the 4, which is equal to t to the 5 over 5 into I plus, and derivative of 4t to the 9, which is equal to 4t to the 10 over 10, integration of 2t to the 5 over 2t to the 6 over 6 into j plus, and integration of 6t to the 10 over 6 to the 11 over 11 plus integration of 3 to the 6 over, and which is equal to 3t to the 7 over 7 into k. And upper and lower limits are 1 and 0 respectively. Putting the lower and upper limits, and we have 2 over 9 plus 1 over 5 into I plus 2 over 5 plus 1 over 3 into j plus 6 over 11 plus 3 over 7 into k. So after some calculation, and we have 19 over 45 I plus 11 over 15 j plus 75 over 75 k. This is the answer of this part. So we dive into second part of this question. So first of all, we calculate the line integral along C1. Along the line segment C1 from 0, 000 to 1000 and x varies from 0 to 1, but y and z are constant, it means remains 0. So putting y is equal to 0 and z is equal to 0 in equation 1 and 3 we have phi is equal to 0 but dr is equal to dxi. Here you can see that only one variable involved, which is x, so we apply the limits of x, but you know that phi is already 0, so complete this line integral is 0. So integral c1 phi dr, which is equal to 0, and now we calculate the line integral along c2. Along the line segment c2 from 1 0 0 to 1 1 0, y varies from 0 to 1 but x remains constant, it means 1, and z remains constant, it means 0. So putting x is equal to 1 and z is equal to 0 in equation 1 and 3 we have phi is equal to y and r is equal to dyj. Here you know that only one variable involved, which is y, so we have the limits of y is 0 and 1. So apply all of these values of phi and y in line integral and also apply the upper and lower limits of y. So integral c2 phi dr, which is equal to integral 0 to 1 y dyj. Here we apply the power rule of integration and we have y square over 2j. So upper limit is 1 and lower limit is 0. So apply the upper and lower limits and we have 1 over 2j. Now we calculate the line integral along c3. Along the line segment C3 from 110 to 111. X varies from 0 to 1 but both x and y remains constant, it means 1. So putting x is equal to 1 and y is equal to 1 in equation 1 and 3 we have phi is equal to x plus 1 and dr is equal to dzk. You can see that only one variable involved, which is z. So we have the limits of z, which is 0 and 1. So putting all of these values of phi, dr and lower and upper limits of z in integral formula, and we have integral c phi dr, which is equal to integral 0 to 1 2x plus I into dzk. So after integration we have z squared plus z into k, applying the upper and lower limits, and we have which is equal to 2k. This is the answer of c3. Add all of these curves and we have the complete value of line integral. So integral c phi dr, which is equal to integral c1 phi dr plus integral c2 phi dr plus integral c3 phi dr. So putting the values of c1 c2 and c3, and we have 1 over 2j plus 2k. So this is the final answer of the second part of this example. So I hope guys you will learn very well, but if you have any question, please comment me. I will give you complete answer immediately. Thanks for watching and see you in next example.